Okay, 2-point charges have a force of repulsion of 56 newtons when they are 45 centimeters from each other. And what separation is there? It's going to be closer, right? Because it's more force, so therefore it'll be a smaller number than 45. Okay, so let's call this F1. Let's call this R1. Let's call this R2 that we're trying to solve for. Let's call that F2. All right, so F1 is KQ over R1 squared, and F2 is KQ over R2 squared. Okay, and we're solving for the R's. Oh, that's too tricky. If I divide them though, left over left, right over right, that goes away and you end up with what? F1 over F2 equals R1 squared over R2 squared. Right, it's whoops, 2 and 1. That's a 2. There we go. Because it's 1 over 1 over, right? So it flips that over. Okay, that's like the worst. Let's write it again. Okay, and so we're solving for, it looks like we're solving for R2, right? So R2 is going to be the square root of F1 over F2 times R1, right? If you solve that for R2, right? So R2 is the square root of, F1 is 56. We'll see if this makes sense, 98. Okay, and then R1 is 45. Looks like it's right, okay? I know it should be the square root. I know it should be a smaller number than 45 because it's a bigger force, so I'm going to go with it. Okay, 98. And 56. All right, 98, 56 times 45. Ooh, baby. 34.02. 0.0168 centimeters. Now notice that we put centimeters in there, right? You know, we're playing fast and easy, but you know, the units of this cancel out, right? These are newtons and newtons, and whenever you take a square root of something, you better not have any units, because what would square root of newtons be, right? Nobody knows. Okay, but this thing on the back side here has the units of centimeters, so therefore this has centimeters. So 34.0 centimeters is the new radius. Ta-da!